Good morning, dear students. I am Monika, Assistant Professor, PG Department of Computer Science, Arya College, Ludhiana, and today we are going to discuss what is operating system and CPU scheduling. So, first of all, we will discuss what is operating system. Operating system, its definition, introduction to operating system, services provided by operating system, and types of operating system. Then we will discuss what is CPU scheduling, its basic criteria, its concept, different type of algorithm used in CPU scheduling with examples. So first of all, we will discuss what is an operating system. So an operating system is as an intermediary between user and system. So it is a set of programs or software which helps us to perform work. Like if we are a user of the computer and if we want to access some devices or we have to execute some program, we have to take the help of operating system. Operating system will help us to communicate with the computer. Then we have some services of operating system, like what kind of services an operating system performs, like user interface, program execution, file system manipulation, input output operations, resource allocation, error detection, accounting, protection and security, command interpretation, resource manager. Then we will have some types of operating systems. So depending upon the type of task or the type of processor, we have certain types of operating system in our system. Like we have batch operating system, multi-programming, multi-processing, multitasking, real-time. In real-time, we have certain types, like we have soft real-time, hard real-time. We have distributed operating system, we have time sharing operating system, we have network operating system. So these are the types of operating system we have in our system. Then it comes with the concept of CPU scheduling. Now, how CPU works or how CPU manage to execute task. Like when we have to execute some program or some processes, how the CPU will process or execute it so that it will be utilized fully and it consume less time and less memory. So we have multi-programming, jobs, user, processes, input output burst cycle, and primitive scheduling. So in this we will see that what a scheduler do. Scheduler selects from among all the processes in the memory that are ready to execute and allocates the CPU to one of them. Then CPU scheduling decision may take place when a process, number one, switches from running to waiting state, switches from running to ready state, switching from waiting to ready, and then it terminates. Next, scheduling under 1 and 4 is non-preemptive. All other scheduling is preemptive. So number 1 and the number 4 is a non-preemptive task and other are the preemptive. So now we will discuss what is a dispatcher. A dispatcher module gives control of CPU to the process selected by the short-term scheduler. It involves context switching, switching to user mode, jumping to a proper location in user program to restart that program. Then we have CPU scheduling. In CPU scheduling, we have some performance criteria, like under what kind of criteria a CPU have to perform. So we have here utilization, like the fraction of time a device in its use, it is utilization. Throughput, the number of job completed in a period of time, that is a throughput. Then service time, the time required by a device to handle request. Then queuing time, time on a queue waiting for services from the device. Then the residence time, the time spent by a request at a device. Residence time is equal to service time plus queuing time. Then we have response time, time used by a system to respond to a user job. Then the think time, the time spent by the user of an interactive system to figure out the next request. Then we have CPU scheduling. In this, we will discuss CPU scheduling algorithm. Like we have four kinds of algorithm. First one is first come first serve, then shortest job first, then we have priority scheduling, and we have round robin scheduling. The first come first serve and the shortest job first, they comes under the non-preemptive scheduling, and the round robin and priority, they come under the preemptive scheduling. So in first come first serve, its idea is very simple. Like what we like, if we have a queue and we are at the first position, we will be served first. We can take this like example of a ticket counter. If we are standing next to the ticket counter, and if we are at the number one place, we will get the ticket first, and the person who is at the last of the ticket counter will get the ticket at the last. So same as in the concept of this first come first serve, the processes that are firstly arrived, they will be executed first. So here we can see we have 1, 2 and 3, 4 processes, and according to that they are executed like P1, P2, P3, P4. They are executed in a proper sequence. The way they come, they are executed. Then we have shortest job first. Now in this system, we will see that the job or a process that have a minimum burst time or minimum execution time, it will be served first, and in it the criteria will be time or a burst time. Like if it have a shortest burst time, it will execute first, and if it has a long short burst time, it will be executed at the last. So in this example, we can see this like we have 1, 2, 3, 4 processes. So in this, the 8, 4, 9, 5, these are the service time or a burst time. So in this manner they are executed. Like first of all, we will execute the P process, which is a second process. It have a burst time of 4 seconds. So it will execute first. Then we will have the next job, which is at number 4 of 5 seconds. Then we have 8 at the process number 1. Then it will execute. And at last, the process number 3 will be executed because it have the maximum burst time. Now, the third algorithm is priority based scheduling algorithm. So in this, it will execute simply, but it will assign a priority number to the processes. Like we have 10 processes in our ready queue, and we will assign all the processes and priority number like 1, 2, 3, 4, 5. So the number or a process which have a highest priority, it will be served first. Like we can take an example of a VIP. Like if VIP comes in a queue, we will serve it first. Same with the concept of CPU, we will assign priority number to the processes, and if that process come, we will execute it on a priority base. Next one is round robin algorithm. In this algorithm, we will tend to move the CPU. Like in round robin algorithm, the criteria will be time quantum. We will give all the processes a time quantum of let's say 4 second or 5 second. So we will assign the processor or a CPU one by one to all the processes for a 5 seconds each. So in this manner, we will able to be uh, execute all the processes one by one, and it comes under the preemptive algorithm category. In this, we will have a time slicer. In round robin algorithm, it will use a timer to cause an interrupt after a predetermined time, preempts if task exceed its quantum, or train of events dispatch, time slice occur, or processes suspend on event, put processor on some queue and dispatch the next. In round robin, we will have a time quantum. It is very important to have a time quantum. We will fix some sort of seconds for the time quantum, let's say 5 seconds, 4 seconds, 10 seconds, and depending upon that, we will execute the processes. So in this, we will have processes, arrival time and service time, or we can say burst time. So in this, each process will have a time of 4 seconds each, like P1 will be executed with 4 seconds, then 4 seconds for the P2, then 4 for P3, then 4 for the P4. Then again P1 for the 4 seconds, P3 for the 4 seconds, then the rest of the time will be served. So this was all done with the CPU scheduling, and with the wrap up, we will discuss that what will we did today. We discussed the operating system, its types, its services, and we discussed the types of CPU scheduling algorithm with some examples. So thank you so much.